Good day everyone and welcome back to the channel. So this is going to be the last video that I make before the amp gets put together basically. So I've turned the diodes around, I have sorted out all the resistors so the bias is correct, there's no offset, the amp's up and running now. I've only done it with this one half, so I still got to do it with the other half. But I was thinking about it, and yeah, obviously I've got these 47 mic caps that I've got to change for the good quality ones, and these ones here. I was thinking about it, and I've decided I'm going to do all the upgrades first before I go and put it together. Because yeah, once I put it in the case, I don't want to go pulling it all back out of the case. You know what I mean? That's just going to really piss me off. So what I'm going to do in this video is go over why I'm doing what I'm doing, you know, from the research I've been doing the last few weeks and little experiments here and there designing this. I've come up with better ways of doing things, and so some things are going to get put back in the component drawers and replaced with other things, sort of just like what happened here with the output components and stuff like that. So I'm going to start off with this board because I'm already certain of what I'm going to be doing with this. So with this board, there are these 220 Mylar caps that are on the pre-driver circuitry. They're going to be replaced with those, so 2 for each board. The 100 nanofarad Mylar caps will be changed with these. So these, it's 4 per board, so it's going to be a grand total of 8. So 8 of them, 4 of those, right? I've decided on these MKS4 caps that are on the, what do you call it, the bias. I've decided I'm going to use the smallest MKP caps I could get, which were these. So 4 of those. On the, hey, get off the table now. On the bridge rectifiers, I made these snubbers with 400 volt capacitors. I don't have many of those. I've only got 10 and that's 8 of them gone. So I would rather have those for purposes when I need a 400 volt cap. So what I'm going to do with those is I'm going to replace those with 8 of these. These are 10 nanofarad, same as what they are, but these are 100 volt 10 nanofarad capacitors. So that's the upgrades on that. Oh, and one more thing. On the capacitor banks, actually this is a 2-part thing. So one thing is these MKTs that I've got, they got steel legs, and I'm not sure what the foil is inside, but I got these, which are a higher quality one. They have a lower ESR, they have copper legs, and apparently a copper foil. I don't know if that's true or not. I'll do some parameter testing and see if the claimed differences are true or not. If they are, I'll change them. If not, let's do it now. Why talk about it? Let's do it. So I'm interested around 1 kilohertz and up. These capacitors are for high frequency. Actually, we'll go up to 10 kilohertz. So these have an ESR of 0.14 of an ohm at 10 kilohertz and a dissipation factor of 0.010. I actually have two other candidates, to tell you the truth, but these are the ones that I used. Same dissipation factor. Is that the same ESR? So I'm not changing them. They can stay as they are, and just for shits and gigs we'll test these. Even worse. Alright, so there you go. So that's not getting changed. That's staying as it is. So this can go back over here with the parts that are actually going to go in the build. Alright. Now, this is where I need to show you guys a couple of things on the computer, so I'm just going to pause the video for a second, get this ready. Actually, sorry, my apologies, my bad. There was something else I decided to do. These 4 diodes that are in the bias string, I've decided to replace them with Schottky diodes. Haven't decided what type yet. Could be like a 1N58, 19, 58, 17. What have I got? Let's see. 58 22s, 58 19s. You know, I've got some BAT series, BAT 48s, BAT 46s, BAT 42s. I'll work out what diode's got the smallest junction capacitance and the highest forward voltage for a Schottky, because they're replacing silicon diodes, and I'll choose that diode. So that's going to happen as well. Right. There's nothing else on here that I'm missing, is there? Ah, yes, one thing. The capacitors, I've got those 47 mic cheapos in there at the moment for the constant current source references. They're going to be replaced with proper nice Nichicons, like all the other ones on here are all nice capacitors. So that's what's going to happen. I'm just going to quickly go off now and work out what diodes I'm going to use, because it only take me literally 2 minutes to work that out, and then I can show you guys what we're going to use. Alright, I had a look between 1N5711s, 5822s, 5819s, BAT 42, BAT 46, BAT 48, and I chose BAT 46, which is incidentally the same diode that's in here. The reverse protection diode across the BIOS network. So BAT 46. If you look at SAP series output devices, the incorporated diode string inside those devices is actually a mixture of PN junctions and Schottky junction diodes, which is now what my BIOS string is. Hey. And they're bloody nice transistors. So, anyway, now for things that I haven't decided upon yet that we're going to look at and see if it's worth doing or not. So, first thing to do, let's open the dissipation factor and ESR. I'm more concerned about dissipation factor on these. That was already on it. So core at 0.5. 0.55. The Muse series 25 volt 100 microfarad. Double. So I was right. The larger, higher voltage cap is the better option. So there you go. These we'll use for the next amplifier build, because I want to build a few amplifiers. Some are going to be medium quality, which that will go in. Some are just going to be average quality. Some are going to be test amps. So yeah, they'll get used pretty soon. After this is done, we'll do something else, and then after that's done, we'll get back to amp building and use them. Okay, as you guys know, I've got polystyrene caps coming because I'm going to make the compensation network 2-pole output inclusive 2-pole compensation. What else? I think that's it for this board, apart from, you know, the other upgrades that are going to come after all of this is done. The amps are in a box and running. Then I might take the boards out, you know, and start looking at, you know, VU meters, speaker protection, better current sources or references for the current sources, linear regulation for the VAS and driver circuitry, positive and negative rails, stuff like that. But that's, you know, first I want to do these upgrades, get the amp going. Then I want to possibly experiment with different transistor types if I'm not happy with the performance of it. If I am happy with the performance of it, then we'll add these things I was just talking about. So now you may be asking, what else am I going to do? Oh, and by the way, I've left the offset pots off because there's a reason for this. The emitter resistor of the VAS transistor, the beta enhanced transistor, the collector resistor off of your collector and emitter resistors off of the input section, they actually also affect the offset, and those values may get changed for better square wave response and stuff like that, which will potentially make the offset better or worse. So I'm going to leave it without the pots. There's basically no offset anyway as it is, and if that's needed, then at a later stage they will get fitted. Right, what's the last upgrade that I was talking about doing? Okay, so let me just get some schematics up on the computer screen. So, unlock my focus. All the amplifiers I've looked at that are blameless style modifications or just plain blameless amps, you know, the capacitor across the driver, the base sucker capacitor, the last one, I always see 1 microfarad and 100 nano on the stage before it if there's a driver stage. And I can show you again, 1 microfarad, 47 mic on the, what do you call it? VB multiplier. I always use 4.7. I've got my own reasons for that. What have we got here? We don't have one. You get really bad cross distortion if those resistor values are too high and there's no capacitor there, I can tell you that. This guy's got 10 microfarads. That is a shit amp. That is shit too. Let's see. 1 microfarad. So here's what I was thinking of doing. There's got to be a reason for that. Guess what I got? Nothing but the best MKP4s. So what I'm going to do, which is funny because I originally put MKTs on here, then changed them for MKP4s but 0.1s. I'm going to take those 0.1s off and put them where the 10 nanofarads are. And where the 100 nanofarads were, I'm going to put 1 microfarads. So I still got quite a few components to fit, and you're all probably laughing at me because of how many things I've soldered and then desoldered and put back in drawers. But honestly, normally this would be a pain in the butt for most people because all the legs I've formed up and bent. But for me, because of the way I make my circuit boards, it's just going to be easy when I go to use those components again because they'll already be formed up. So it actually isn't a problem for me. um, anyway, I'm going to go get all this done. I'm not going to do this on camera. I just wanted to give you guys a look at what changes I'm going to make to it so that, you know, when I come to building day, people aren't looking at it going, what? That looks totally different. You'll know exactly what I've done, why I've done it, blah, blah, blah. Oh, actually, there was one other change / upgrade that I've got to make as well. One moment. So at the time when I put these 100 picofarad polystyrene capacitors just in here, across the 15k resistor to ground on the input, I only had these little 50 volt style ones that were in this form factor. I've now, because I've ordered more, I've got 100 picofarad, 100 volt rated ones in a much bigger package. Copper legs as well. I'm going to measure the parameters on this and compare it to the parameters on those ones. And if these are better, they will be swapped as well. I am literally trying to do everything the best I can. I mean, I used the best transistors I could for the current source for the input section. The input pairs perfectly matched, best transistors you could get. Same with the current mirror. Same with the beta enhanced transistor. The fast transistor and pre-drivers have got such a small cob and high FT for what they are, they're just amazing, you know. The MJ15033s and 15032s, their gain doesn't fall off until like, I don't know, 4 or 5 amps or something like that, which they're never going to get up there. So they're going to have really good gain all the way through the power band. The output devices have got really good gain. Actually, that's on Semi's what they call gain matched and gain guaranteed something. They guarantee that it's going to have a certain gain with the NPN and PNP devices will be within 10% of each other. And they also guarantee that the gain won't start to fall off under a certain current. So I didn't mention a lot of that when I designed this. There's so much in my mind that, you know, it's hard to remember everything and tell you guys everything. But basically, this thing's designed with, and also 2 transistors per channel. So because of the gain characteristics of the driver stage, the output transistors, how many of them there are, that alone is going to make it quite a load invariant amplifier. And then because of the work that's done on this board, you know, low cob, high FT, really nicely done circuitry, you know, the THD is going to be through the floor. So, you know, you can't blame me for putting effort in. That's what I'm trying to do. You know, this is my own personal amp. I wanted to build something that's, you know, on par with what people spend, you know, $40,000-$50,000 on. But I don't want to go and spend that money on a Macintosh amp when I can go build it myself and get the same quality. I just think that's retarded. I mean, most of you people who build stuff probably understand where I'm coming from there. So, yeah, that's the method to my madness, if anyone's wondering. All right. Well, I will get to doing this. I'll give you guys a look at everything maybe when it's done, or I might just upload the video as it is. I'll probably just upload the video as it is, just so you guys know what changes to expect. So like I said, when it comes to putting it together day, which will be the next video, you guys aren't looking at it thinking that I've done a whole load of work off camera because it didn't work. everything is here in front of you and explained to you. I'm sure you can understand it's not going to affect the circuitry. The only thing here that might actually affect the operation is these diodes. With a few milliamps through them, their forward voltage should be about 350, 400 millivolts drop. These with 4 milliamps through them, I don't know, it might be 700, 800 millivolts, 900 millivolts. You know, the bias is going to be a bit lower. The bias is already too high anyway. I've already considered this, so it's perfect, you know. So, yep, that's that. Small little update video for you guys. And the next video you'll see will be this being put together in a case, and we'll be, you know, adjusting bias for the perfect crossover point, testing cross distortion and offset again, and should that all be good, we'll be loading it up. All right, well, thanks for watching everybody, and I'll see you all soon. Small update. Apparently I did have 2 left, and you can see that the last 2 in here are slightly smaller than the new ones that I've bought. But I got another 10. So due to the fact that these are for clamping spikes anyway, the 400 volt ones are probably nicer. Might even have a lower ESR. I'm just going to leave those. It's more work anyway, and I've got more, so who cares. So I'm just going to get this stuff fitted to the amps, and that's it. Everything else is good the way it is. The other thing I forgot to mention, and this could be a bit of a problem. So the capacitor banks that I made, they're 63 volt capacitors. I thought my transformers were going to make 55 volt rails after rectification, but it turns out that it's going to be 63 volt rails. So I'm umming and ahhing what to do about that. I've got a few options. Use them. They'll probably be all right. Use those big honking things that I've got that are 100 volt 10,000 mic, and it's big tanks. Or use these for now and order, you know, 75 or 100 volt 4700 mic caps to replace all the caps on the cap bank with high voltage ones. But I just thought I'd point that out. I've had a think about something else too. At the moment, the output compensations has got a 47 picofarad capacitor across it, because after doing further research before it, I found out that it wasn't really right. I can't remember what happened, what conclusion I came to. I've just got these components in a bag, and I know that I'm waiting for more polystyrene caps to arrive, which probably get here tomorrow or the day after. I'll work that out as well and fit that, and we'll take it from there basically. Or I might work it out and decide to just leave that until the amp's up and running, and then we'll investigate different forms of 2-pole output inclusive compensation with different values. But yeah, so that's that. Update out. I'll see you all soon.